The third category is mixed numbers. Mixed numbers mean we've got a whole number and a proper fraction. So this kind is known as mixed numbers. The first type was proper fractions, which is lesser than one whole. The second type is improper fractions, which is greater than one whole. And the third type is mixed numbers, which is another representation of improper fractions. Here we've got 1 whole, 1 over 2. I'll just quickly do another example for you. For example, it's 7 over 2, 7 over 5. 7 over 5, I'm talking about this one here. 7 and 5, 5 ones are 5, 2 left. So that's 1 whole and 2 over 7. I'm sorry, it's 2 over 5. Okay, so that's 1 whole and 2 parts out of 5 that we're talking about. 1 whole can also be written as 5 over 5 plus 2 over 5. Denominators are same. This becomes 7 over 5. That's the conversion between improper fraction and mixed numbers. Moving on, when we talk about comparison of fractions, we're talking about rearranging them in ascending or descending order. Now, ascending order means the smallest value comes first and the biggest value comes in the end. Ascending. I'll quickly repeat, from the smallest to the biggest. For example, 2, 3, 4, 5. 2 is the smallest value, 5 is the largest value. So 2 comes first, then comes bigger than 2, that's 3, then comes bigger than 3, that's 4, so on and so forth. So the smallest value coming first and the biggest value or the largest value coming in the end. For example, I've got 3 fractions here, 3 over 4, 5 over 6 and 5 over 9. For example, I've got a square here to represent each of these. The size of the square, the holes are same, okay? The first one is split between 4 parts and we're talking about 3 parts out of 4. The second one is split between 6 parts. Okay, just ignore my drawing please. 5 parts, that's 1, 2, 3, 4, 5. We're talking 5 here. The third one, this is this one, this is this one, and this is the last one. The third fraction is split between 9 parts and we're talking about 5 parts. So that's 1, 2, 3, 4, 5. Now before we start arranging them in any order, be it ascending or descending, the size of this part needs to be same. Now if you see here, the whole is same, it's this one square, but it's split between different sizes of parts. So the first thing we need to do is we need to convert all of these into equal sized parts. Now for that, we're talking about finding the lowest multiple. 2 times 4, 2 3 times 6 and 9 as it is. 2 1 times 2. 3 and 9 come down as it is, they're not divisible by 2. 3 1 times 3, 3 3 times 9, and 3 1 times 3 and 3 1 times 3. 2 2 times 4, 4 3 times 12, 12 3 times 36. So if I split each square into 36 parts, then the size of the part I will get is same. 4 how many times is 36? 4 9 times is 36. So for this, I will multiply the denominator by 9 and the numerator by 9 as well, because I need to keep the balance here. 6 how many times is 6? 6 times is 36. So times 6 and times 6. 9 4 times is 36. So times 4 times 4. Now I'll just write down these fractions again. 9 3 times 27, that's 27 upon 36. That's 5 6 times 30, 30 upon 36. And 4 5 times 20, so that's 20 upon, sorry, that's 36, 36. Arranging in ascending order, meaning smallest to biggest. 20 parts out of 36 passes smallest value. So 20 upon 36 comes first. Next is 27 over 36, and last is 30 over 36. This is arranged in ascending order. I just write on ASC, okay? So you know it's an ascending order. Similarly, descending order is biggest to smallest. That's descending. Converting the same one into descending. Now the biggest come first. That's 30 over 36. Then smaller than 30. That's 27 over 36. And then the smallest will be 20 over 36. This is, I'll just write on DEC. This is descending order. I hope that's clear here. Moving on to equivalent fractions. That's the last part of this video. Equivalent fractions are those which on simplification are equal. For example, I've got two fractions, 6 over 12 and 4 over 8. I need to simplify these quickly. 6 1 times 6, 6 2 times 12. 4 1 times 4, 4 2 times 12. They are both simplified to 1 over 2, which is equal. Hence 6 over 12 is equal to 4 over 8. All of these are equal to 1 over 2. So any basically fraction which is simplified to 1 over 2, the ratio 1 over 2, all of them would be equivalent. Similarly, 5 over 10 and so on and so forth. There are plenty of them more. Lastly, I'll quickly talk about simplification now. Simplification of fractions means, for example, you've got an expression that's 1 over 3 multiplied by a bracket open 1 over 4 minus 1 over 12 plus 1 over 2. We need to simplify the bracket first, meaning we need to subtract or add them first. For that, we need the denominator same. Now taking the LCM of 4, 12 and 2, we'll quickly do this side. 4, 12 and 2. 2 times 4, 2 6 times 12, 2 1 times 2. 2 1 times, 2 3 times, and 1 3. 1 times is 3. 2 2 times 4, 4 3 times 12. So the LCM is 12. That's 1 over 3. 4 how many times is 12? 4 3 times 12. So the numerator also gets multiplied by 3. 4 3 times 12, that's how the denominator here. 3 1 times 3. We get a 3 here. 12 1 times 12, don't need to multiply this by anything. So 1 in the numerator comes as it is. 2 6 times 12. 2 6 times 12, so 1 6 times is 6. 3 minus 1 is 2. 2 plus 6 is 8. That's 1 over 3 times 8 over 12. Let's see if we can simplify the fractions here. 4 2 times 8. 4 3 times 12. I've got 1 over 3 times 2 over 3. In a multiplication sign, no LCMs needed. We just multiply the numerators and multiply the denominators. 1 times 2 is 2. 3 times 3 is 9. That's how we simplify. Thanks for watching this video. Hope this was helpful. Stay tuned on the page. Share with your friends. Give me feedback. Tell us what we can do better.